This mathematical structure is what is called a complex fraction. It's called a complex fraction because it's a fraction that contains a fraction in its numerator and or denominator. In this case, it contains a fraction in both the numerator and denominator. We don't want to leave this fraction in its complex state. We would like to simplify it. Well, maybe we wouldn't, but mathematicians would like us to. So we want to try to simplify that complex fraction by making the fractions within the fraction disappear. I'm probably not going to be able to make the fraction disappear completely, but I'd like to be able to make this fraction and this fraction disappear. Now, if I were to multiply this fraction by x, wouldn't that fraction disappear because the x's would cancel? But here, it would take a multiplication by x squared, wouldn't it? Wouldn't it take a multiplication by x squared to cancel the x squared in the denominator of that fraction? Well, I can't multiply the numerator of a fraction by one quantity and the denominator by a different quantity. I will destroy the value of the fraction. But I could multiply them both by the same quantity. If I multiply that fraction by x squared over x squared, haven't I really just multiplied that fraction by 1 as long as x isn't 0? And x couldn't be 0 because I couldn't have 0 for x in the original complex fraction. So I'm just multiplying that fraction by 1, which isn't going to change the fraction's value. It's going to change its appearance, make it less complicated, change it from a complex fraction to a simple fraction, but it's not going to change the value of that fraction. So let's multiply the numerator of this fraction and the denominator of this fraction by x squared. Well, these are terms. Don't I have to multiply each of these terms by x squared? So it's going to be 1 multiplied times x squared, which is just x squared, plus 1 over x multiplied times x squared, over 1 times x squared is x squared, minus 1 over x squared multiplied times x squared. I had to, in effect, distribute the multiplication across both of the terms that were here in the numerator and denominator of the complex fraction. So this gives me x squared plus, well, isn't that going to be x squared plus x? Because this x will take out one of the two x's that are there, over x squared minus 1, right? The x squareds will cancel to 1. And now I would look to see if there might be any further simplifying I can do by looking to see if these binomials are factorable and possibly I have a common factor I can cancel out. Well, I hope we recognize x squared minus 1. That's x minus 1 times x plus 1, right? Isn't that the difference of squares? X squared minus 1 squared. And can't I factor a common factor of x out of each of those terms? X squared plus x could be factored into x times the binomial x plus 1. And now I have common factors that can be canceled. And our simplified fraction is x over x minus 1. These two fractions, the one we started with originally, which has kind of been a little distorted now with what we were doing, but the one we started with originally and this fraction have the same value. By that I mean, if we were to pick a value to plug in for x, whatever value we plugged in for x, if we do the arithmetic and get that value, if we take the same x and plug it in here and do the arithmetic, it will be the same value. And I think you would agree this particular fraction would be much easier to evaluate for a given value of x than what this original complex fraction would be. And that's the reason we simplify complex fractions, is to make working with them further much less difficult.